Well, good evening, students. Today we're meeting to talk about page 5 and 6 homework. So let's go through a couple of these. This is over Lewis dot structures. This is found in your notes on pages 8 and 9. So remember, dot structures is real simple. You're just looking at dots and you're drawing dots out. And the first one, you're figuring out what group they're in. And you can do that two ways. But on this, you do it one way. So you have 1, 2, 3, 4, 5, 6, 7. So there's 7 dots. So that means they're in group 17. And the group name for group 17 is your halogens group. Okay. Zinc, its own special thing. It has 2 dots. It's actually in group 12. And if you look at zinc, it's located in group 12, and that is part of the transition metals. Okay. So remember, look at how many dots you have. That tells you the group number. If it's over 2, so if it's 3 or higher, then it would be something like 13 through 18. Okay, so if it has 3 or more dots, it's 13 through 18 group. Okay, and then the group names, you just name it as this: alkaline metals, alkali earth metals, whatever. All right, so to draw the dot structures on the next section, not that hard. Find the element, figure out what group it's in. So for example, aluminum's in group 13. You only pay attention to that second number. So you draw aluminum, 1 dot, 2 dot, 3 dot. Okay. Same with sulfur. Sulfur is in group 16. Sorry about that. I would use my periodic table. That would help me out a little bit. Remember, you only pay attention to that last number. Sulfur would have 6 dots. Okay. All right. Down here to isotopes. Remember, the only thing that makes an isotope different, it has a different number of neutrons. So you do everything the same way. So for example, we have krypton. This is 86 as its isotope. Remember, you have these two numbers. The top number is your mass number. The bottom number is your atomic number. So that goes here. Remember that your protons and your electrons are the same number. And then what you're going to do is you're going to subtract mass number minus number of protons. So 86 minus 36 is 50, and there's my answer. Okay, so if we go down, let's do number 3. So here's my protons. Remember, protons are the same as the electrons. They're the same as the atomic number. And because atomic number is 31, I'm going to have to look that up and figure out what element that is. So let me pull out my handy dandy periodic table, because I don't want to tell you wrong. And that's gallium. So symbol is Ga. Now, I don't know my mass number yet. I have to figure that out. Remember, mass number is just number of protons plus the number of neutrons. So 31 plus 41 is 71. So mass number goes on top, mass number goes there, and then your atomic number goes on the bottom there. And then the molar mass for that element is 69.723. All right, so that's how you do it. So remember, protons, electrons are the same, and those are the same as the atomic number. Find the mass number, you add protons and neutrons, and then you figure out your element. This is your mass number. This is your atomic number. This is your mass number. There's your symbol. Okay? All right, let's get down here and do some of the bottoms. All right, let's do some of these down here at the bottom. So we'll do number 8, number 9. So tritium is an isotope of hydrogen with 2 neutrons. How many protons? Well, remember, what element is hydrogen? Hydrogen is element number 1. So it has 1 proton. Remember, because it's neutral, it has 1 electron. So let's look at number 9. Lead 206 is a byproduct of a certain nuclear reaction. So how many neutrons does lead have? Well, first we have to figure out that lead is element number 82. Well, that's how many electrons it has. So that's how many protons it has. So what are we going to have to do? Subtract 206 from 82. And that gives you 4. And that gives you 12. So your answer would be 124. Okay? So that's the front part. Flip it over to page 6 in the back. So once again, we have isotopes. Remember, in isotopes, the element number of protons stays the same. Only thing different is the number of neutrons. So the atomic number for oxygen is 16. Okay. And so actually, in this one, you cannot do this problem. So there's no solution. Because if you subtracted 16 from 16, you would be left with 0. And that's not a possible answer. Okay. So, oh, my bad. I messed up. If I was using my periodic table like I should be doing, I would remember atomic number is 8. So yes, you can do that. You can fix that. So if the atomic number is 8, then I know that means there's 8 protons, so I know it can't be that answer. And so then what I need to do is subtract mass number from atomic number. 16 minus 8 is 8. So what has 8 neutrons? The answer would be B. Okay, let's do a different one. I screwed that one up. Number 12. Aluminum. Remember the atomic number for aluminum is 13. So based on that, it can't be this or this because it has to be protons or 13. And then all I would do is 27 minus 13 equals 14. And I'm left with answer A. Okay? All right. Remember 14 through 18 is basically periodic table work. So if you look at the periodic table, the atomic mass is equal to the molar mass. So for example, the atomic mass of carbon is 12.011. So the molar mass of carbon is 12.011. Okay, this is simply off the periodic table. That's all you do. All right, let's go to these bottom 4. Let's do a couple of these. We'll do uranium. I kind of like uranium. So remember, bottom number is always your atomic number. And your atomic number is always your number of protons and your number of electrons. Remember ape man. So atomic number, number of protons, number of electrons, mass number, atomic number, subtracted equals the number of neutrons. Okay? So 92, 92, 238 minus 92, that's 6. Carry my 1, 146. Okay? So that's how you do those. We'll do lithium. We'll do the easy one. So remember, 3 is my bottom number. That's my atomic number. So it's also my protons and electron number. Subtract these two numbers, you get 4. That's your neutron number. Okay, good. So that's all the homework for page 5 and 6. And good luck.